Hi, welcome to section 5.2, factoring trinomials where the leading coefficient is 1. So hopefully by the end of this, you all will be able to factor trinomials where the leading coefficient is 1. So a reminder, factoring is reverse multiplying. So I want to start for a second with a multiplying problem that we might have seen in chapter 4. So something like x plus 3 times x minus 7. If you had to multiply that, you would probably distribute. You would do x times x, which is x squared. You do x times the negative 7 and get negative 7x. You do 3 times x, which is 3x, and 3 times negative 7, which is negative 21. And you'd probably even combine those like terms in the middle. And negative 7x plus 3x is negative 4x. So I've got x squared minus 4x minus 21. Now with factoring, we're going backwards. They're going to give you x squared minus 4x minus 21, and then your answer is going to be x plus 3x minus 7. So we need to think about, how do we go in reverse? How do I get back there? So I want you guys to think for a second about where these terms came from so that we can go backwards. So where did that first term, where did the x squared, where did it come from? Well, the x squared came from multiply the x times the x. It came from me multiplying the first times the first with those binomials. All right, well, how about the last term? That one's not too bad to think about. Where did the negative 21 come from? Well, negative 21 came from me multiplying the 3 and the negative 7, so that was the last term times the last term to get to the negative 21. And the more interesting one is probably that middle term, isn't it? Because where did the negative 4x come from? Well, we had to go back a step and say the negative 4x came from me adding negative 7x and 3x. Well, where did those come from? All right, well, the negative 7x came from me multiplying x and negative 7. So those were the outside ones multiplied together. Where did the 3x come from? That came from me multiplying the 3 and the x together. Those were the inside ones. So where does that middle term come from? It comes from the outer product plus the inner product added together, okay? So what we're going to do is called guess and check factoring. And guess and check factoring is where we use this information to go backwards. So we're going to unmultiply using this. So what we're going to be doing is we're going to be guessing. We're going to be guessing so that those first ones multiply to give you the first term. We're going to guess so that the last terms multiply to give you the last term. And a lot of the time, you're going to have more than one combination. Even for 21, we could have 3 and 7, or we could have 21 and 1. You know, and then we're going to decide, well, which one is the right one? Is that the right guess? By checking with the middle term. And so you check that we have the right combination if the outer product plus the inner product gives you the middle term. All right, so let's start with one. We've got x squared plus 6x minus 27. All right, so I know the format that this is going to be because we have this trinomial. I know it's going to look like binomial times binomial. I know it's going to be a couple sets of parentheses. I'm going to guess so that the first times the first gives me x squared. Well, the only way that I'm going to multiply to give me x squared would be x times x. So I'm going to guess with that. Then the last times the last needs to multiply to give me a negative 27. So with negative 27, we have some options. We could do 9 times negative 3. We could do negative 9 times a positive 3. We could do 27 times negative 1 or negative 27 times a positive 1. We've got 4 choices, and then we're going to see which one works. All right. Well, with 9 times negative 3, that would be a positive 9 and a negative 3, like that. So one thing that I'm going to notice here, every single one of these combinations had one positive and one negative, so I know I'm going to have a plus and a minus. It's just a matter of which is which. So let's check and see if this one works. So our check is going to be the outer, so that's x times negative 3, which is negative 3x, plus the inner, so that's 9 times x, which would be 9x. And negative 3x plus 9x is 6x. It's positive 6x, just like we wanted for our middle term. We did awesome, and we are factored. That's it. So the factoring hint for you guys on this one is if you have a negative last term, you will definitely have a plus and a minus for your signs inside those binomials. All right, let's do another one. Next one I have is y squared minus 14y plus 24. All right, I know the format, so I know to start out with two sets of parentheses. My first times my first should give me y squared. So the only way I'm going to do that is y times y. All right, my last times my last needs to multiply to give me 24. And it's positive. So what I can tell about that is that positive things come from either a positive times a positive or a negative times a negative. So I look at my middle term to determine which one it's going to be. Is it going to be positive times positive or negative times negative? I see a negative 14y in the middle. That lets me know that it's going to be a negative times a negative because two positive things added together is not going to give me a negative. But two negative numbers added together will give me a negative. All right, so let's talk about the 24. We have all sorts of options with 24. Let's see, we could have 24 and 1. We could have 12 and 2. We could have 8 and 3. We could have 6 and 4. Lots of choices. I'm trying to get to 14 though. And if I look at this, 24 and 1 is probably going to give me 25, isn't it? 12 and 2, well 12 plus 2 would be 14. Let's try that one. Let's try 12 and 2, and let's check that. So if I check, y times negative 2 would give me negative 2y. Negative 12 times y would give me negative 12y. Negative 2y plus negative 12y is negative 14y. We did it. And there's our answer is y minus 12 times y minus 2. So a little hint for you guys here. To add, if the last term is positive, I know that the signs are the same. And then you look at the middle term to determine what the sign is. All right, next one. We've got t squared plus 11t plus 12. All right, so I start out with my parentheses. To get t squared, I'm going to do t and t. To get a positive 12, we know it's going to be the same signs. I look to my middle term, and I know that my signs are going to be plus and plus. So then I look at 12. All right, my options for 12 would be 12 times 1. It could be 6 times 2, or it could be 4 times 3. Those are my choices. So let's try it. If I do 12 times 1, let's check. That would be t plus 12t, which would give me 13t. That's not what I'm looking for. That choice doesn't work. All right, and you probably like to do a lot of these with a pencil and erasers, so I'm going to erase that. Let's try the next one. What if I do 6 and 2? All right, that would check to give me a 2t plus 6t, which would be 8t, and that is not what I'm looking for, so I'm going to cross that one out and erase. All right, what about my last one, 4 and 3? 4 and 3, I would have 3t plus 4t, which would give me 7t, and that doesn't work either. And so you'll notice we have exhausted all of our choices. None of those work. And if nothing works and it's not factorable, there's a math word for it, and it is called prime. That means I can't factor it. So that's your new hint to add to our list. If a polynomial cannot be factored, it's called prime. All right, this one looks fun and complicated, doesn't it? I've got 5x to the third plus 35x squared y plus 50x y squared. One thing you'll notice with this one is it doesn't start with an x squared, and the leading coefficient isn't 1, and that looks complicated. One really big hint for all factoring here on out, always look for a GCF first. If you can get that GCF factored out at the very beginning, your life gets made a lot easier. So when I see 5, 35, and 50, they're all divisible by 5. Let's factor out a 5. When I see an x to the third, an x squared, and an x, I can also factor out an x from all of that. So let's go ahead and factor out that GCF to make our lives easier. So remember, GCF factoring, we're unmultiplying. So I'm thinking 5x times what gives me 5x to the third? Well, that would multiply by x squared to get that original term. All right, 5 times what gives me 35? That would be 7. Let's see, x times what gives me x squared? It would just need to multiply by an x, and we still have a y there. Plus, 5 times what gives me 50? It would be 5 times 10. Let's see, we had an x and we unmultiplied it, so we're just left with y squared. So there's the end of our GCF factoring. And then you should always think, well, can I do more? Now that I factor out the GCF, can I do the guess and check factoring now? Let's try it, okay? So the first times the first should multiply to give us our first term. So what times what gives me x squared? It would have to be x and x. All right, the last term is positive, which means the signs are the same. I look to my middle term, which is positive, so now I know my signs are plus and plus. All right, my last term should multiply to give me 10y squared. So to get the y squared, what's going to happen is each term is going to have its own y. And when we're checking, we're going to have like an xy over here and an xy over there, which is going to help us with that middle term. So let's think about the numbers. Thankfully, 10 doesn't have too many factors. We're either looking at 10 times 1 or 5 times 2. To get 7, how about we try 5 and 2, since 5 plus 2 is 7. I'm going to try 5y and 2y. And then you check. So if I want to check my outside, the x times 2y would be 2xy. I just like writing my letters in alphabetical order so it's nice and consistent. The inside, when I have 5y times x, that would be 5xy. Again, I'm just rearranging so my letters are alphabetical. So then you can see that they're like terms. They both have xy's. 2xy plus 5xy is 7xy, which is perfectly what we're looking for. So we have guess and check factored that. In case you're wondering, like, what do we do with that 5x that we factored out at the beginning? Don't forget about it. It's part of our polynomial. It's part of our expression, and you just bring it down. So this whole thing right here is our answer, 5x times x plus 5y times x plus 2y. That whole thing is your answer. So your factoring hint, and I put it in bold because it really is what I would always look for first, is always look for that GCF first. Now it's your all's turn. You get to try one and show me how much you've learned.